In this video, we're going to be looking at the higher GCSE mini test 1 that comes from mathsgenie.co.uk, and we're going to go through the solutions to each question. So, question 1 is an algebraic fraction question. We're asked to simplify fully. Now, with an algebraic fraction, we're asked to simplify where we've got quadratics. Our first step should be to factorize. I'm going to factorize the denominator first here because it does not have a coefficient of x squared that is greater than 1. So x squared subtract 7x plus 10 goes to x. I'm looking for a pair that add to 10 and a pair that add to negative 7 and multiply to 10. So I could be looking at 10 and 1, 5 and 2, negative 5 and negative 2 work here. So I've got x minus 5 and x subtract 2 for my denominator. My numerator, I've got 3x squared subtract 7x plus 10. So to factorize that, I'm going to do 3 times 10 first, which is 30. So I'm now looking for a pair of numbers that multiply to make 30. Add to make negative 17, so that would be negative 15 and negative 2, so I get 3x squared subtract 15x subtract 2x add 10, and then factorize the two parts that I've got there, and so I get 3x and then x subtract 5 on one side, then I need x subtract 5 in the brackets on the other, so that's going to be minus 2 x subtract 5. So my full factorization is 3x subtract 2, x subtract 5. That's my numerator. So I've got 3x subtract 2, x subtract 5. I've got x subtract 5 as part of my numerator and denominator, so I can divide 3 by x subtract 5, giving me a final answer of 3x subtract 2 over x subtract 2. This would probably be a 3-mark question. You'd get 1 mark for doing a correct factorization of the numerator or denominator. The second mark would come from factorizing both parts successfully, and the final mark would be for writing the correct answer. Question 2 gives you a triangle. It's not right angled, but it tells you the area is 55 square centimeters. We've got 2 side lengths, we've got the angle between them. That immediately indicates that we're going to be using trigonometric formula for the area of the triangle, half AB sine C. Well, here we've got A and B, but we don't have C. C is x, C is our unknown. So we're going to form an equation. We've got 55, because that's the area, is equal to a half times 10 times 16 times sine C. Simplifying that right hand side, we get 55 from the left is equal to half times 10, which is 5, times by 16, which is 80. So 55 is equal to 80 sine C. Divide 3 by 80, so 55 over 80 equals sine C. And then we take the inverse sine function, the arc sine of the left hand side. So sine minus 1 when we type it into our calculator. 55 over 80 is equal to C. Typing that into the calculator, we get sine minus 1 of 55 over 80. Gives us an answer of 43.4325. I'm going to write it out for the first, so if I make an error with the rounding, I can still pick up some credit. And then with the rounding, it says to 1 decimal place, so 43.4 degrees equals C. So question 3, we've got function notation given that f of x equals 2x plus 1 and g of x equals x squared plus 3. Find f g of x. Well, in this case, we've then got f of x squared plus 3, because that's what g of x is. So we're substituting x squared plus 3 for x. F of x, so that's 2 lots of x squared plus 3 plus 1. That would then expand, so 2x squared plus 6 plus 1 to give you a final answer of 2x squared plus 7. This could be a 1 marker, it could be a 2 marker, where you get 1 mark for recognizing the substitution of x squared plus 3 and 1 mark for the final answer. Question 4, we've got the surds, where we're asked to expand a surd expression and give it in the form a plus b root 5, where a and b are integers. The trick to this is that remembrance that when it's squared, we've got the two pairs of binomials. So we've got 4 plus root 5 multiplied by 4 plus root 5. 4 times 4 is 16. 4 times root 5 is 4 root 5. Root 5 times 4 is 4 root 5. Root 5 times root 5 is 5. When we then simplify that, 16 plus 5 is 21. And then 4 root 5 plus 4 root 5 is 8 root 5, giving us 21 plus 8 root 5 as our answer. Probably a 2-mark question here. 1 mark for getting 3 out of these 4 parts of the expansion correct, and then the 2nd mark for getting the final answer. Right, question 5, we have an iteration formula here. Living in a town T years from now is PT, where P0 is equal to 42,000 and PT minus 1 is equal to 1.02 PT minus 550. It asks you to work out the number of people in the town 3 years from now. This would be a calculator question. So P0 is 42,000. So P1, after the first year, that's going to be 1.02. It's a constant, it doesn't change. Multiplied by P0, because that's the one less than our PT minus 1, which we know is 42,000. Subtract 550. And typing that into your calculator, so it's 1.02 multiplied by 42,000, subtract 550, gives you an answer, P1 of 42,279. To work out the second year, you do 1.02, still a constant. We take our previous number, substitute it in. So that's going to be 42,279, subtract 550. Working that out gives you a value of 42,563.58. Now, here you could type in 42,279, or you could use the ANS, the answer button on your calculator, because your previous answer was 42,279. Using the ANS means that when you do the third one, for P3, you don't have to make any edits or changes to your calculation. We'll take 42,563.58. It would be okay here to take 42,563 or 42,564, using either rounding up or saying, well, we've got above, but we won't get an extra 0.58 of a person. It gives you, after your third year, 42,853.8516. As an answer, you would need to then give that as an integer value, but you could round up, you could round down, saying that you wouldn't go above. I'm going to round as I would mathematically here, but it is important that your final answer is an integer. I would imagine that this would be a 3-mark question. First mark for doing the correct substitution or getting the correct answer after year 1. The 2nd mark for the correct process to do it 2 more times. And the 3rd mark for getting the correct answer at the end, 42,854 or 42,853 with that one. So question 6, G is directly proportional to the square root of H when G equals 4, H equals 36, so find the value of H when G equals 2. So we'll set up our proportion equation. G is proportional to root H, so we can rewrite that as G equals K root H. Substitute the values from the question, so 4 equals K root 36, square root of 36, so 4 equals 6K. Divide through by 6, so 2/3 equals K. We now have our constant proportionality, so we can rewrite our original formula there. So G equals 2/3 root H. So if G equals 2, so we've got 2 equals 2/3 root H. multiplied by 3 is 6, divided by 2 is 3, so 3 equals root h. Square both sides, so 9 equals h. This could be 2 or 3 mark question. It might give you a mark for writing the proportionality formula generally. Your second mark would potentially come from working out the value of k, and your third mark would be for substituting and solving. Looking at it, I'd say probably actually a 3 mark question, maybe even 4 if they're being generous. Question 7, we've got a bounds question. A is equal to b over c. We want the lower bound for a. So the lower bound for a, well, to get that, we want to minimize the number we're dividing. So we want the lower bound for b. We want to maximize the number we're dividing by. So we want the upper bound for c. The lower bound for b is going to be 9.365. Because 9.37 correct 2 decimal places. The upper bound for c would equal 5.45. And it can't be any higher because it would then round up to 5.5 to 1 decimal place. If we substitute those in, the lower bound for a is equal to 9.365 over 5.45. Typing that into the calculator, 9.365 divided by 5.45 gives you an answer of 1.71834864. Writing it out in full first, then rounding it to the given degree of accuracy, which would be 1.72. This is probably a 3 mark question. The first mark will come from writing a correct bound. The second mark will be substituting the correct bounds in to work out the lower bound for a. And the final mark will be for getting the correct answer. Question 8. We're given a speed time graph and asked to calculate the distance travelled. To calculate distance, that's speed times time. So we're working out here the area under the graph. Now we're split into 3 bits. The dashes on the diagram help indicate that. The first section is a triangle. The base is 30. The height is 20. So it'd be 30 times 20 divided by 2. 30 times 20 is 600. 600 divided by 2 is 300. The middle section is a rectangle. The width is 90, subtract 30, so it's 60. The length is 20, so we do 60 times 20, which is going to give you 1,200. And the final section is another triangle. It's got a base of 130 minus 90, which is 40. A height of 20, so we do 40 times 20. Divide it by 2. 40 times 20 is 800. 800 divided by 2 is 400. The total distance will be the sum of those 3 values. So 1,200 add 400 add 300. Remember, we're adding. Adding is commutative. It does not matter the order we do it. Summing those values together gives you a total of 1,900. And our units, the question is meters per second, so our distance will be in meters. This would probably be a 3 mark question. 1 mark for calculating the correct one of the 3 correct areas. Second mark for a correct process to calculate all 3 areas. Final mark for the correct answer. Question 9. Here's the point 21 on the circle, x squared plus y squared equals 5. Work out the equation of the tangent to the circle at P. So we know we've got a circle. X squared plus y squared means its center is at 0, 0. The point 21, so 2, 1, it's going to be a point about there. So we want the equation of the tangent, we want the equation of the line that touches that circle at that point. So the first thing that we need is the equation, or the gradient at least, of the radius, because we know that the radius and the tangent meet at 90 degrees. The radius goes 2 squares along, 1 square up. So the gradient of the radius is going to equal a half. Well, the gradient of the tangent will be the negative reciprocal of that. And so that will be -2. We then use our formula for a straight line, y equals mx plus c. In this case, our value of y is 1, comes from the point. The gradient is -2. The value of x is 2, and c is what we need to work out. Also, 1 equals -4 at c. If we add 4 to each side, we get 5 equals c. So we've now got 5 equals c is our y-intercept. Our gradient of the tangent is -2. So the equation of the tangent will be y equals -2x add 5. It would also be okay to write that as y equals 5 minus 2x. This would potentially be a 4-mark question, maybe potentially even 5 marks. 1 mark for calculating the gradient of the radius, the 2nd mark for the gradient of the tangent, 3rd mark for the correct process to get the y-intercept, and the 4th mark for writing the equation. So yeah, probably 4 marks on that one. So question 10, the coordinates of the turning points of a curve are 1, 4. Write down the coordinates of the turning point of the curve of the equation y equals f brackets x plus 3. So the turning point of a curve is y equals fx. F brackets x plus 3, well, it's inside the bracket, so it's going to affect the x coordinate. That means the y coordinate will not move, so in our vector it's 0. If it's add 3, remember inside the brackets it's the opposite, so the x translation is going to be -3. There's no negatives involved, no negative x or negative f of x, so there's no reflection involved. So it's been translated by a vector -3, 0. If it's 1, 4, translated by a vector -3, 0, that goes to the point -2, 4. That would be your solution on that question. So question 11, prove that the sum of the squares of any 2 consecutive integers is always an odd number. So our consecutive integers would be n and n plus 1. The sum of the squares, so we need to take the squares, so n squared plus n plus 1 all squared. N squared is obviously just n squared. N plus 1 all squared. We expand those brackets. Remember, it would be a set of 2 pairs, so that would go to n squared plus 2n plus 1. Simplify that, we get 2n squared plus 2n plus 1. Now we've got a few ways we could do this. That would be even, that would be even, that would be odd. Even plus odd will result in an odd number. Or proving it algebraically, we factorize the first 2 terms, so 2 brackets n squared plus n, then we add 1. This means this section is even, because we've got that factor of 2, plus 1, that's adding odd, so our answer is odd. Potentially a 3-mark question here. First mark for writing the correct expressions for n squared and n plus 1 all squared. 2nd mark for expanding and simplifying, and the final mark for writing the conclusion. Question 12. 10 counters in a bag, 6 of the counters are red, 4 of the counters are blue, 2 counters are taken at random from the bag. Work out the probability that 1 counter of each colour is taken. This one would be useful just to sketch a probability diagram, 3 diagrams. We've got red and blue for the first counter, red, blue for the second, and red, blue for the second over here. Initially, 6 of 10 are red, so we've got 6/10 red, 4/10 blue. If we selected a red counter, the problem that the second counter is red would then be 5/9. Probability that it's blue, well, there's 4 blue left out of 9 in total. If the first counter selected was blue, then we'd have 6 red out of 9. But 3 out of 9 blue. The 2 we're interested in are 1 of each colour, so that's 6/10 times 4/9 of going red then blue. That's going to give us 24/90. The second one, 4/10 times 6/9. 4/10 times 6/9. That's 24/90 as well. Final bit, we need to combine those, so 24/90 add 24/90 will give you an answer of 48/90ths. No need to simplify it here. It's a probability question. Simplifying could just encourage you to just allow a mistake to creep in. Probably you're looking at 3, maybe 4 marks here. 1 for a correct tree diagram with some correct working with the reduced probabilities. 2nd mark would be for 1 correct calculation. 3rd mark would be 2 correct calculations and the full process. 4th mark would be for getting the correct answer. So, question 13. Solve x squared plus 10x plus 21 is greater than or equal to 0. So, first thing we need to find the critical value. So we're going to factorize. We've got x plus 7, x plus 3 is greater than or equal to 0. So we know that our critical points are x equals -7 and x equals -3. Sketching out the graph, there's one possible solution. So we've got a point at -7, point at -3. The graph will sketch like that because it's a positive coefficient of x squared. It's just 1x squared. We want it greater than 0, so we need the bits over here and over here because that's where it is greater than 0. So our solution is that x is less than or equal to -7, or that x is greater than or equal to -3. You get 1 mark probably for correct factorizing, 2nd mark for working out the critical points, and then the 3rd mark will probably come from writing the correct inequalities. So in this question, we are asked to solve the simultaneous equations. We can see that the first one is quadratic, the 2nd one is linear. But so we've got the first one in terms of y. We might as well just substitute that whole expression into y in the second for y in the 2nd equation. So doing that, we get x plus 2 lots of x squared, add 3x, subtract 18. And we've got the add 14 outside the brackets equals 0. We want to expand and then simplify. So we've got x plus 2x squared plus 6x, subtract 36, add 14 equals 0. If we then simplify that, we get 2x squared, add 7x, subtract 22 equals 0. I want to factorize this, so I've got 2 and -22, so 2 times -22 equals -44. I'm looking for a pair of numbers that multiply to make -44, but that add to make a +7. Well, the 2 numbers there add to make -7, add to make +7, so that's going to be +11. So I'll have add 11x, subtract 4x, subtract 22 equals 0. We want to factorize the 2 parts of that expression. The first one, we'll go to x and then in brackets 2x add 11. Therefore, the 2nd one, we need to have 2x add 11 in, so we can take out a factor of -2, and then 2x add 11 equals 0. So our final factorized version there is 2x add 11, x subtract 2 equals 0. So our values for x equals -11/2 from the first bracket, or x equals 2. To find the value of y, we need to substitute that in. We can substitute it into the first one, but that would involve probably then using a calculator. If we substitute it into the 2nd one, we get -11/2, add 2y, add 14 equals 0. -11/2 is -5.5. If I add that to 14, I get -8.5. So 2y, I get 8.5. But I want to subtract that, so that's 2y equals -8.5. So y is equal to -4.25. For the right hand side, for the 2nd one, for x equals 2, we get 2 plus 2y plus 14 equals 0. So 2y at 16 equals 0. So 2y equals -16. So y equals -8. Our final solutions are that x equals -11/2 or -5.5 and y equals negative 4.25, or x equals 2 and y equals negative 8. This here would be 4 or 5 marks. You'd get 1 mark for doing a correct substitution, eliminating one variable. Second mark for then a correct approach to find that variable, so the factorizing and the solving, so the values for x. Third mark would be for substituting it in to find at least one value of y. The fourth mark would be for getting a full correct approach to get one solution. The fifth mark would be getting 2 full correct solutions. 15, we have a relatively straightforward complete the square here. Remember, to find the value of a, we halve the coefficient of x. So we've got x add 5 all squared. When we do that, when we expand those brackets, we get the x squared, we get the 10x, but we also get 5 squared, which we need to remove. So we want to subtract 5 squared, and then add 5. Simplifying that, we get x plus 5 all squared, subtract 25, add 5. And fully simplified, that would be x plus 5 all squared, subtract 20. I'd expect 2 marks on this question, 1 for getting the x plus 5 inside the brackets, the second mark for calculating the subtract 20 outside. For question 16, we're asked to prove algebraically that the recurring decimal 0.4 with the 0.9 with the 0.9 recurring can be written as 9/22. So we start, we'll call n is equal to 0.409 recurring. Therefore, 10n would be 4.09 with the 0.9 recurring. 100n would equal to 40.90 with the 90 recurring. And 1000n would equal to 409.09 with the 0.9 recurring. At this point, I've got 2 values which have the same recurring part. So if I do 1000n, subtract 10n, that's the same as then doing 409.09 recurring, subtract 4.09 recurring. If I do that, I get 990n is equal to 405. The recurring has been eliminated. I then want to simplify this. They can both be divided by 5. 990 divided by 5 would give me 198n. 405 divided by 5 will give me 405 divided by 5. Why has my mind just gone blank for a moment? Give me 81. I know I want to end up with 22 as my denominator. I can see that they both divide by 9 here. If I divide the left-hand side by 9, I get 22n. The right-hand side divided by 9 is 9, so n is equal to 9/22. You could also, at this stage, the first stage there, you could have written n is equal to 405/990 and then simplified as fractions rather than simplifying the equation. You'd probably get 2 or 3 marks on this question. The first one would be for writing any of 10n, 100n, 1000n. Second mark would be for a correct approach to eliminate the recurring part. The third mark would be for the full proof. Question 17, we've got about cylinders, we're talking about mathematical similarity, we're talking about lengths, and then we're talking about volumes. Well, if the length of cylinder A is 6 and the length of cylinder B is 12, the scale factor for lengths is going to be 12 divided by 6, so 2. That's the scale factor, and it's the scale factor for lengths. The scale factor for volume is going to equal 2 cubed. So the volume scale factor is 80. If cylinder A is 80 centimeters squared, the volume of A, we're going to need to times by 8. So we'd want to do 80 times 8. That's going to give us 640 centimeters cubed. This one, potentially 2, maybe 3 marks on it. The first mark would be for working out the volume scale factor of 8. The second mark would be for correct calculation to get the correct answer of 640. They might break that down and give an extra mark. In 18, we're looking to prove congruency. That means we need to make sure that one of our conditions of congruency are held. So we're asking to prove triangle ABE, which is the one I'm just going around in blue here, and triangle CDE, which is the one in green here. Now, we're looking for things that match up. The first thing that I can notice here is that triangle AEB is equal to angle CED because opposite angles are equal. It's important to state something that's equal and give the reason. I know that E is the midpoint of AC, so that means that AE and EC are also equal. E is the midpoint of AC. And therefore the two lines must be equal. The same can be said about BE and ED. So BE equals ED, again because E is the midpoint, this time of BD. Now I've got three conditions, I've got three things here. I've got an angle, I've got a side, I've got a side. The angle is between the two sides, so I can use side, angle, side, and that proves congruency. This you're probably looking at 3 marks, 1 mark for a correct statement, 2 marks for all 3 correct, 2 marks, second mark for a second correct statement with reasons, and the third mark for the full proof. Question 19, we're looking at the quadratic sequence. So first thing we're going to do is we're going to look at the differences. We've got subtract 2, subtract 4, subtract 6, subtract 8. So the second difference is that's subtract 2, that's subtract 2, that's subtract 2. So my coefficient of n squared will be negative 1n squared, because my coefficient of n squared is going to be half the second difference, provided the second difference is constant. So for the first term, negative 1 times 1 squared is going to be negative 1. Then we go negative 4, negative 9, negative 16, negative 25. Once we've taken that out, so if we do that, the sequence subtract the 1n squared, the negative 1n squared, we've got 6, 7, 8, 9, 10. Now that rule is going up by 1, so part of our rule is going to be n, and our rule there of 0 term would be n plus 5. So altogether, our rule would be negative 1n squared plus n plus 5. Also written as negative n squared plus n plus 5, or 5 plus n subtract n squared. You're looking probably 3 marks on this. 1 mark for working with the second difference and identifying the coefficient of negative 1. Second mark for a correct approach to get the n plus 5 part. And the final mark for getting the full answer here. And question 20, sketch the graph of y equals sine x for 0 is less than or equal to x, which is less than or equal to 360. So sine x crosses the y-axis at 0. So we've got 0 in the middle, we've got 1 at the top, 0 and negative 1. And then it will peak at 90, cross over again at 180, and then 270, it will have a minimum, and 360, it will be back to 0. And then our curve will loop around like this. You're not going to get marks for being perfect on this. It needs to be the general sketch, hit the key points. Probably looking at 2 marks for this, 1 for the hitting general points, 1 for guessing the shape correct. And that concludes the